Welcome, everybody. As you can see, today's MooreChat is our second MooreChat. It's called Brace for It. So Matt's going to be talking about things that fall down. Matthew, his contact details are here on the slide, so you want to take a screenshot of that. But you can also go into the chat box and open it. And inside there, we've dropped information as well. So without further ado, I'd like to welcome you all and introduce Matt. Matt Pavelchak is a principal in our Houston office. He's been with Walter P. Moore almost 11 and a half years. He came to us from Purdue University, and he's the leader of our litigation group. So welcome, everybody, and Matt, take it away.
Perfect. Thank you for the introduction, Dan. Today, for our 10-minute MooreChat, we'll be talking about the importance of bracing during construction and erection. And we'll start off with a couple examples, walk through the importance of having bracing during construction, and talk about some resources that are available, and then have time for questions. So jumping into this, we'll start with a couple project highlights here of some collapses that have occurred. And this first one, you can see a pre-engineered metal building that collapsed actually in the middle of the night. So most likely due to wind loading. And the collapse, after we reviewed it, was determined to be because of a lack of adequate construction bracing to handle the lateral load, such as wind, at the time of the collapse. And similar to the second case study we'll look at, you can see that this was a bare steel frame at the time. The non-structural elements such as shear walls and other components that would act as the lateral load resisting system in the permanent configuration were not constructed at this time. Luckily, in this scenario, nobody was seriously hurt. The second example was a high school auditorium under construction, and you can see some relatively tall two-story mezzanine areas here. And unfortunately, in this project, a worker was fatally injured as a result of the falling steel that he was tied off to coming down upon him as the collapse occurred. And this collapse occurred during active erection under the erection loads that were being placed as steel was being erected. And you can see from sort of surveying the remainder of the frame here, there's no bracing, cabling, or other temporary supports to provide that construction temporary lateral load resisting system. Similar to most school construction, as you can imagine, the exterior walls of the building and the completed structure would be a CMU wall, and that would serve as the shear wall to handle lateral loads when the structure was completed. But obviously, at this stage in construction, that shear wall hadn't begun to be constructed yet. So when we talk about construction bracing, it's really required for all steel frames and for most precast and tilt-up concrete applications, as well as for other types of structural systems. And you can see the picture here is some cable braces or guy wires that are installed in an X pattern on this steel frame. And this is the most common type of bracing you'll likely see in low-rise steel construction. Certainly, there's other types of bracing elements that could be used in precast and tilt-up construction. Pipe braces would be the most common type that you'd see, but there's a number of ways that you can go about providing for those temporary lateral loads. And really, if you think about what is the bracing there for, I've put this quick statement here that the bracing is required to resist the lateral loads until the permanent lateral load resisting system is engaged. And the structural engineer of record on your project should be indicating what that permanent lateral load resisting system is. But until that time that it's constructed and engaged, it's up to the contractor to provide adequate lateral support. And so if we talk about, why is bracing required in the first place? If we take a simple representation of a steel frame here that's, being erected, and before you've grouted the base plates, before you've installed shear walls or other systems within the building, it's still subject to some horizontal loads. generally not as large a magnitude as you'll have in the completed structure, but horizontal loads nonetheless. And these would include things like wind, erection loads from working the steel, and stability loads, things like initial out of plumbness that create some loads on the structure. And the way I've drawn this here, if we kind of did a free body diagram and decided whether or not this is stable, it's really only stable if you can develop a significant moment across the base of these columns that have been erected. And that's really the only mechanism that would keep this simple example stable. But if you look at a typical configuration, the detail on the left here is a pretty typical precast concrete column configuration, but not significantly different than what you'll see in steel construction. You'll typically have 4 anchor bolts at the corners of the base plates, and then you'll typically have a shim pack at the center of the column. And that helps the erector be able to get the right elevations and to be able to plumb up the building. And in this erected sequence, there's going to be a period of time when those base plates are ungrouted, and really all your column loads are being transferred by that shim pack represented by the black rectangle there at the center of the column. And if you kind of think about that from classical, structural design, that's really pretty close to just having a perfect pin condition where the column is resting on a single point at the center of its section. And so when you think about this configuration, it's not capable of resisting much moment, if any. And so if we go back to this example and we apply that horizontal load, knowing that we have very little residual moment capacity at the base of the columns at this stage in construction, you apply that horizontal load and you're going to get some rotation, and eventually that rotation will increase and you'll end up with a collapse. And so, how does bracing resolve that? And so here we've added to this simple example that cable bracing we saw in the example photo a few slides earlier. And if you apply that same horizontal force, now you can develop a tension in one of the cables, and then that tension is applied as a shear across the base plate. And so you can see that in this scenario, it allows you to transfer the load in a way that the base plate of the column can resist. And obviously, you've got the cable bracing in both directions because cables can only take load and tension. And so if you think about this example and you reverse the direction of the horizontal load, the opposite cable will be engaged. And that's why you always, or generally always, install them in an X pattern like this. So that is why it's required and how you can resolve those forces in the field. And as far as references and go-bys, there's two predominant references, among others, would be the American Institute of Steel Construction Design Guide 10, shown here on the left, which is for erection bracing of low-rise structural steel buildings. And so it has prescriptive examples where you don't have to run any calculations if you meet their requirements, which are limited to a 2-story building or 60 feet in height, whichever is less. And obviously, if you have a taller building, you can use the same principles. You just need to apply some engineering design and judgment to it to extend those examples to a more complicated structure with larger demands. Similarly, the Precast Concrete Institute Erector's Manual provides guidelines and rules of thumb and examples for how to brace pre-stressed concrete structures during erection. And I will say that the PCI requires that there be a submitted erection bracing plan that's custom to each project, rather than having the AISC provide some prescriptive methods that you can use without having a formal submittal. Either way, on your project, the design professionals may or may not require that submittal to understand what the plan is during construction. So hopefully that provided an interesting background and some data points on why bracing is important and how it can lead to bad results if it's neglected. And with that, go back to you, Dan Orlich, if there's any questions from the audience.
Thanks, Matt. That was fantastic. I don't have any questions in the chat box, but I did get a text message asking about how often you had seen bracing issues and typically what are the causes that tend to cause them to happen?
Yeah, good question. So we typically see at least one of these sort of cases come across our desk in a year. And so over the course of my career, I've been involved in about a dozen of these where there's been either a partial or a complete collapse related to a lack of bracing. I will say it's one of those where a little bit of bracing goes a long way. And so typically these catastrophic or very dramatic failures occur when bracing is completely omitted. You can certainly have some issues if you make some attempts at bracing and get the detailing wrong. But I think it's more common that, if an honest try at bracing generally gets you enough capacity to get through that construction process and avoid the worst outcome.
Thanks, Matt, for answering that one for the group. I'll open it up. If anybody has a question, please unmute and you can ask Matt a question. You can also type it in the chat box, either to the group or directly to myself or Matt, and we'll answer it for you. These calls are meant to be interactive, so love to hear anybody's perspective or additional questions y'all have. If not, the idea is a quick chat with the expert, learn about a new topic, and our next set of presentations will happen on April 7th. It's going to be Rocky Like a Hurricane. So I'll open this up. Does anybody have any questions? From NC State would like to know what kind of cables were used?
So the capacity of the cables that are typically used would be described in AISC Design Guide 10, as well as the type of turnbuckles that you'd use to suture them or to tie them off at the ends. And there's the requirements there for having some redundancy. The diameter of the cable that you'll use will somewhat depend on the load that you're dealing with. And so it could vary based on the application.
You can go to www.walterpmoore.com/MooreChat. If you go onto there, you'll be able to see last week's one that David Ford did on building enclosure. Matt should be loaded in about the next 48 hours or so. Coming up, we have on April 7th, Rocky Like a Hurricane, April 21st, Before the Rain Comes, and May 5th, BEC, Common Misconceptions. And then finally wrapping up, our springtime exposure will be enclosure waterproofing done right. I think that'll be a great one, be a big audience for that one. Find more information at walterpmoore.com/MooreChat, and we look forward to having you on the next call.